So for this proof, you're going to start writing down the givens. AB is congruent to AC. That was given. Mark it. AB is congruent to AC. Next, you're told AD bisects angle BAC. That's not anything that we can directly mark until we interpret it. So if you bisect an angle, it means you cut that angle into two congruent angles. So here's angle BAC. I'll follow it with my cursor. If it's bisected, it's cut in half, so you get these two pieces. But that's not what we wrote yet, so we're going to write that. Angle BAD is congruent to angle CAD. And we got that because we were talking about the word bisect, so that's the definition of bisect. Additionally, if we're looking at this as two separate triangles, they both have AD there in the middle. AD is congruent to AD. That's reflexive property. So now we've got, with those two triangles we were just talking about, they each have corresponding sides congruent, corresponding angles congruent, and another corresponding side. Two sides, the angles in between. So that's going to be side angle side. Show that those two triangles, triangle BAD is congruent to triangle CAD. So since those triangles are congruent, triangle on the left, triangle on the right, they're congruent. All of their parts are congruent. So even these angles right here, BDA is congruent to angle CDA. That's true because those are corresponding parts of congruent triangles, so they're congruent, CPCTC. So those angles are congruent. We also can tell just by looking at them that those two angles, BDA and CDA, they're also a linear pair, so they're supplementary. Are supplementary, I'll bring you later. We know that they're supplementary because they're a linear pair. Now, we're trying to say that angle BDA is a right angle. So if they are congruent and they're supplementary to each other, that means they're equal and they add to 180. There's only one number plus itself that's going to equal 180, and that's 90. So angle BDA, we'll word it the way we need to, is a right angle. Because BDA and CDA are both congruent and supplementary, and that's a good enough reason. I'm just going to write congruent and supplementary. So if they're equal and add to 180, that means they're both 90. They're both right angles. So that's the whole proof. Full credit. So we are starting with A and B. They're parallel. So if we're doing the proof, that's what we're going to write first. A is parallel to B, given. Now, since those lines are parallel, you get corresponding alternate interior, alternate exterior, whatever you need from it. So we're trying to tie 2 and 8 together to be supplementary. So 2 and 8. Since they're on different sides of the line, let's bring them together first using something like corresponding or alternate interior, whatever we wanted to use from that. So to bring 2 closer to 8, let's bring it from this intersection down to here by doing corresponding. Angle 2 is congruent to angle 6 because they are corresponding. Angle 2 is congruent to angle 6. Now we're trying to tie that to 8. Now that we've tied 2 to 6, can we tie 6 to 8? Angle 6 and angle 8 are a linear pair, which means they're supplementary, because they are a linear pair. So there's only one step left to finish it off. We're supposed to say 2 and 8 are supplementary. We just said 6 and 8 are supplementary. So we need to replace that 6 with a 2, which we can do. So 6 and 2 are congruent, so we can replace 6 with a 2. That's just called substitution. That's it.